Hi, welcome to Mathmaxtra. This is Saritha. Today our topic is rectangle. So we will first know what is a rectangle is. Rectangle is nothing but it is a quadrilateral in which the pair of opposite sides are parallel and one of the interior angle is 90 degrees. Then we call that quadrilateral as a rectangle. See, first, it should be a quadrilateral in which the opposite sides are parallel. See, these are opposite sides, and this is one pair of opposite sides, and this is another pair of opposite sides, isn't it? And along with that pair of opposite sides are parallel, we should have one of the interior angle is 90 degrees, which is nothing but this is 90 degrees. Now these two are parallel and these two are parallel. One of the interior angle is 90 degrees. Then we call this quadrilateral as a rectangle. Okay. And if you want to tell the definition of rectangle in terms of parallelogram, see, we have a parallelogram. In parallelogram, we know that the pair of opposite sides are parallel, and along with that condition, what we are doing? We are doing one of the interior angle as a 90 degrees. Means we are making one of the interior angle is 90 degrees. What happens? This is the angle, right? We are extending this angle to up to 90 degrees, which is nothing but isn't it? Similarly, and we should make this angle also equal to 90 degrees, right? Which is, yes, now this ABCD. So the first ABEF is a parallelogram and we are making one of the angle as a 90 degrees. Means we are extending this angle up to 90 degrees. Then it will be look like this, which is this is 90 degrees and this is 90 degrees, isn't it? So then we call this as a rectangle. This is the definition in terms of parallelogram. A parallelogram in which one of the interior angle is 90 degrees, then we call this as a rectangle. Okay. Now we will discuss different properties of rectangle. As rectangle is a parallelogram, it holds all the properties of parallelogram. Okay. Along with that, it has some more properties. That is, you take one rectangle. This is a rectangle. We know that according to the definition, the pair of opposite sides are parallel, right? So, the pair of opposite sides are not only parallel, they are equal. Means this side is equal to this side and this side is equal to this side. And these two are parallel and these two are parallel. Okay. And in the rectangle, we have all the angles are 90 degrees only. See, if you make one angle as a 90 degrees, automatically other angles will become 90 degrees. So, we have all angles are equal and each measures 90 degrees. We have all angles are equal and each measures 90 degrees. And the opposite sides are equal. Okay. This is the property of rectangle. And if you, the second property is, see, in the case of parallelogram, what we have seen, the diagonals always bisect each other, isn't it? So, in the case of rectangle, along with the bisection, they are also equal. Okay. So, in the case of rectangle, the diagonals of the rectangle are bisect each other and they are equal. See, if you draw the two diagonals in this rectangle, AC and BD. Okay. So, this is the bisection point of these two diagonals. And we know that Along with the bisection, we know that the diagonals are equivalent, which is nothing but AC is equal to BD. Okay. So this is the bisection point, which is nothing but AO is equal to OC as well as BO is equal to OD. Okay. AO is equal to OC and BO is equal to OD. So as we know that these are equal in length, as the diagonals are equal in length, and we can know that from this is also equivalent to this, because this is the midpoint of both and both are equal in length. So this is the midpoint of this diagonal as well as this is the midpoint of this diagonal, and each segment measures same length. Okay, the segment of the diagonal AO, OC, OB, OD all measures equal length. Okay, so that we can represent like this. Okay. Third property is, you take one rectangle. This is a rectangle ABCD. Now if you draw one diagonal, so this diagonal divide this rectangle into two congruent right angle triangles. See, as this is 90 degrees, this is one right angle triangle, ABC is one right angle triangle, isn't it? And if this is, as this is 90 degrees and this ADC is also one right angle triangle, isn't it? So this diagonal divide the rectangle into two congruent right angle triangles. See, how can we say these two ABC and ADC right angle triangles are congruent to each other? Now see, this side is equivalent to this side. Okay, and this side is equivalent to this side, isn't it? And this side is automatically equal, right? So according to SSS, we have these two triangles are congruent to each other, or you can check RHS also, right angle hypotenuse side theorem also, that will also hold for this. See, 90 degrees and 90 degrees right angle, and hypotenuse AC is very common hypotenuse for both the triangles, isn't it? And one of the side must be equal. Yes, we have two sides are also equal. Okay, so this is right angle hypotenuse side. According to that axiom also, we can say this ABC triangle ABC is congruent to CDA, isn't it? See, AB is equivalent to CD and BC is equivalent to AD and AC is equivalent to AC, isn't it? So these two are congruent triangles, and not only congruent, they are congruent right angled triangles. Okay. This length of the diagonal we can measure this AC is equal to, which is nothing but the root of AB square plus BC square, isn't it? The length of the diagonal is equivalent to AB square plus BC square. Okay, this is the length of the diagonal, and you can also measure BD length. What happens if you draw BD diagonal here? So from this you can write that length of BD is also equal to AB square plus AD square. Okay, as this is a right angle triangle, it holds the property that the hypotenuse square is equal to sum of the squares of the sides. Okay, so by that we can calculate length of the diagonal of a rectangle. See, if you draw two diagonals of a rectangle, these two diagonals divide the rectangle into four equal area triangles. See, this this triangle area, this is the common point of the diagonals, and this AOB triangle, AOD triangle, DOC triangle and BOC triangle. All the triangles have equal area, and along with that the opposite triangles are isosceles triangles. You check, as this part of the diagonal is equal to this part, isn't it? And this part of the diagonal is equal to this part, and these two are equal as the diagonals of the rectangle are equal. So what can we say from this? this is an isosceles triangle as well as this is also an isosceles triangle. So the two diagonals of a rectangle divide the rectangle into four equal area triangles. Along with that, the opposite triangles are isosceles triangles. Okay, and they are congruent. And you take any point in the interior of a rectangle. So I am considering the point here. So you take any point, interior point of a rectangle. If you join this point with the vertices, see, if this is a point O, I am joining OA and OD and OC, OB. So what is the relation of this? So if we consider any interior point of a rectangle, it holds the relation that this AO square and OC square. AO square plus OC square, which is equal to OB square plus OD square. OB square plus OD square. This relation holds always. So in the rectangle, if you consider any interior point, if you join that point with all vertices, it holds the relation that sum of the squares of the opposite vertices, see, OA square and OC square, which is equal to sum of the squares of the other two vertices. Okay, see, OB square plus OD square. This is possible only in case of rectangle. Okay, a quadrilateral is a rectangle if it holds any one of these properties. See, if it is mentioned that the all angles are equal, then what happens? If all angles are equal, each measures 90 degrees, then it will automatically the opposite sides are parallel as well as equal, and the two pairs of opposite sides are parallel and equal, and each measures 90 degrees. So automatically it will become rectangle. Or if diagonals equal and bisect each other, if the given statement is the diagonals are equal and bisect each other, then also you should identify that the given quadrilateral is a rectangle. Or the two pairs of opposite sides are equal and diagonals are equal. See, the two pairs of opposite sides are equal, along with the diagonals are also equal. If this statement is given, then also you should identify that the given quadrilateral is a rectangle. Or two pairs of opposite angles are equal, two pairs of opposite angles are equal, along with the diagonals are also equal, then also it is a rectangle. If among these four statements any one of the statement is given, there you should identify that it is a rectangle. Okay, so these are the some different properties of rectangle, and we will discuss next topic in the comment session. Thank you.